Hey there, today we are going to learn about the volume of the frustum of a cone, and we are starting right now. So come and join me in the video and let's nail it. So like I said, today we are going to talk about the volume of the frustum of a cone, and let's take a look at this. This is a cone. And to understand the frustum, let's just cut open the cone from here, divide it into two parts so that we have a bottom part. So we have a smaller cone. So if we take away the smaller cone, this top part that you see, which I have selected, that is called the frustum of a cone. Now since this is a cone and a cone has a circular top, let me draw a circle here at the top, and if I cut across the smaller cone also, we'll have a circular bottom as well. Now since the top is circular, it's going to have a radius as well, and the bottom also is a circle, so that also has to have a radius. But as you can see, the larger circle is at the top and the smaller circle is at the bottom, so both the radii are obviously different. So let me call this as R1 and let me call this as R2. Now a cone has a height too, and to draw the height, let me take it from the vertex of the cone to the top of the circular part, and let me call this height as h1. Now we have a smaller cone as well, and as you can see, the radius of the smaller cone is r2 and that also has a height, so let me call that height as h2. Now let us look at the frustum that I showed you in the beginning. So this part of the frustum that we see, that is, if we take out the smaller cone from this, what we are left with is a frustum. So that has a height as well, and as you can see, that height, let us call it as h. A cone has a slant height as well, and let me call the slant height of this bigger cone as L1, and let me call the slant height of the smaller cone as L2. So what we are left with now is the slant height of the frustum, and let me take the slant height and let's call that L. Now before we actually get into finding the volume of the frustum of a cone, I just wanted to tell you guys that I keep doing these things a lot on my channel, and if this is the first time that you are coming here, why don't you just click on the subscribe button below the video and get subscribed to the channel, and yes, do not forget to hit on the bell notification also. So coming back to the figure, we see that we have a triangle here, and let me name the triangle as ABC. And let me call these points as D and E. Now as you can see, we are looking at two triangles here. One is triangle ABC, which is the larger triangle, and the smaller triangle, which is triangle DEC. Now if you look at angle A and angle D, both are perpendicular to the radius, so those are going to be 90 degrees. If you look at angle C, that is going to be same in both the triangles. So if two angles of a triangle are equal, then they are said to be similar triangles. So therefore triangle ABC is going to be similar to triangle DEC. And if you don't know the properties of a similar triangle, I have done a video on that too, which is linked in the top right corner of the screen. Just click on that and you'll be taken to the video to understand about the properties of a similar triangle. Now from the properties of a similar triangle, we know that the corresponding sides of similar triangles are going to be in the same ratio. So if we look at the corresponding sides of these two triangles, so I'm taking the bases first. So the base of the triangle at top is R1 and the base of the triangle at the bottom is R2. So R1 upon R2 is going to be the same as, let me take the perpendiculars now. The perpendicular of the longer triangle is H1 and the perpendicular or the height of the smaller triangle is going to be H2. So that's going to be equal to H1 upon H2, and those are going to be equal to the hypotenuses, the ratio of the hypotenuses. So hypotenuse of the longer triangle is L1 and obviously hypotenuse of the smaller triangle is L2. Now once we have established this relationship, what we can just do to find the volume of the frustum, as you can see from the figure also, that we have a bigger cone and we have a smaller cone. So if we take the volume of the bigger cone and from that we subtract the volume of the smaller cone, we'll be left with the volume of a frustum. Now we are aware about it that the volume of a cone is obviously 1/3 the volume of a cylinder, so it's going to be 1/3 times pi r square h. And if you haven't seen the video on the volume of a cone also. Let me link it in the top right corner of the screen again, and you can have a look at that. So the volume of the bigger cone is going to be 1 by 3 pi r. Now the radius of the bigger cone is going to be r1, so it's r1 square times the height of the bigger cone, which is h1, minus the volume of the smaller cone, so that's going to be 1 by 3 times pi. Radius of the smaller cone is r2, so r2 square, and height of the smaller cone is h2. Now unfortunately, whenever we have a frustum in a real life, we are never going to get the dimensions of the full cone because we don't know what part of the bigger cone it is. So we are just going to have a look at the frustum, and all we know is the top radius of the frustum, the bottom radius of the frustum, and the height of the frustum. So unfortunately, all these things like h1, h2 and l1, l2, we are not going to know that. We are just going to know r1, r2, h and l. So we will somehow have to find these values of h1 and h2 in terms of h only, and same goes for l. We'll have to find the values of l1 and l2 in terms of l only. Now as you can see from the figure, the height of the frustum h is going to be equal to the height of the bigger cone, which is h1, minus the height of the smaller cone, which is h2. So h is going to be equal to h1 minus h2. And same goes for l. L is going to be the slant height of the bigger cone, which is l1, minus the slant height of the smaller cone, which is l2. So let me have a look at this relationship again, and let me rewrite that. And so r1 upon r2 is going to be h1 upon h2. Now h1 I'm going to write a little differently here. From this relationship, as you can see that h1 will be equal to h2 will go to the other side. So h1 will be equal to h plus h2. So we can write h1 as h plus h2, and in the denominator we have got h2. So that becomes r1 upon r2 is equal to h plus h2 upon h2. Now we can distribute the h2 in the denominator to both these terms. So we get h upon h2 plus h2 upon h2, which is 1. Now I can take 1 to the other side of the equation. So we get r1 upon r2 minus 1. That should be equal to h upon h2. And from this equation, if we want to find the value of h2, or before that, let me just simplify this left hand side. So r1 upon r2 minus 1, that would simplify to r1 minus r2 upon r2. Now we can just take h2 on the left hand side and take all the things on the left hand side to the right. So what we get is that h2 is equal to hr2 upon r1 minus r2. So let me write it at the top here, that h2 is equal to hr2 upon r1 minus r2. Now if we look at this equation again, we had h is equal to h1 minus h2. Now if we want to find out the value of h1, we can say h1 is going to be h plus h2. So substituting the value of h2 in that, we get h1 is equal to h plus, so here I'm going to put the value of h2 that we found out. So that's going to be hr2 upon r1 minus r2. Now let me simplify this. Take the denominator as r1 minus r2. So we get, now r1 minus r2 is going to be multiplied by h. So we get hr1 minus hr2 plus hr2. Now hr2 and hr2 is going to be cancelled out. So we get the value of h1 as hr1 upon r1 minus r2. Let me write that also on the top, that h1 is equal to hr1 upon r1 minus r2. Now let's look at the formula of the volume of a frustum again. Now can you see that the unknown terms that we had, h1 and h2, we have found the values of those in terms of h, the height of the frustum. So let me substitute those values and find out what we get. So the volume of the frustum is then going to be 1 by 3 pi r1 square times h1. So h1 we have just found out, that's going to be hr1 upon r1 minus r2, minus the volume of the smaller cone, which is going to be 1 by 3 pi r2 square times h2, and h2 we have just found out, hr2 upon r1 minus r2. Now simplifying this, we can obviously take a few things common out here. So if I factorize out the 1 by 3, we can factorize out the pi, and we can factorize the h as well. So what will be left inside is with r1 square times r1, which is going to be nothing but r1 cube. That is r1 minus r2, and since we have r1 minus r2 as the denominator of the whole, let me combine it and take the denominator as r1 minus r2. And in the other term, 1 by 3 pi and h has been factorized out. What we are left with is just r2 square times r2, which is nothing but r2 cube. So we have this 1 by 3 pi h times r1 cube minus r2 cube upon r1 minus r2. Now if you remember the algebraic identity a cube minus b cube, we know that we can factorize that as a minus b times a square plus ab plus b square. And since we have got r1 cube minus r2 cube here, I am going to substitute this or factorize r1 cube minus r2 cube, and I can rewrite that as, let me write the whole thing again. So we get 1 by 3 pi h times r1 cube minus r2 cube. I can write it as r1 minus r2 times r1 square plus r1 r2 plus r2 square, and that's going to be whole divided by r1 minus r2. Now r1 minus r2 is common in both the numerator and denominator, so we can cancel that out, and what we are left with is 1 by 3 times pi h, and inside the brackets we've got r1 square. Now let me take this term first, plus r2 square plus r1 times r2. So what we have got here is called the volume of a frustum, my friends, that it's going to be 1 by 3 pi h times r1 square plus r2 square plus r1 r2. Now this is just about the volume. What about the surface area of a cone? We are going to understand that also, and to understand that, just click on this video appearing on the screen right now. You can consider having a look at these other videos also appearing, and you don't forget to click on my picture here on the screen so that you don't miss out on any future video. And as far as the volume of a frustum of a cone is concerned, I think you've nailed it. Take care. God bless.